For residential garages, a good height for recessed lights is generally between 8 and 10 feet. This height provides adequate illumination while also minimizing glare and shadows. There are several factors to consider when deciding on the appropriate height for recessed lighting in a garage. Firstly, aesthetics can play a role. Lower heights can sometimes create a more intimate and cozy ambience in the garage space. Secondly, reduced glare is another benefit of lower lighting. Lower lights can minimize glare that might be reflected off shiny surfaces or artwork that may be present in the garage. Thirdly, fewer shadows are also a positive aspect of lower lighting installations. Lower lights can provide more even illumination, thereby reducing the number of shadows within the space. On the other hand, there are also reasons to consider a higher mounting height for recessed lighting. Firstly, garages with higher ceilings may require higher lights to ensure adequate illumination reaches the floor and work surfaces. Secondly, task lighting is an important consideration. For specific tasks, such as working at a workbench, higher lights can provide improved visibility for detailed work. Thirdly, the desired ambience can also influence the choice of height. Higher lights can create a more airy and spacious feel, particularly in garages that feature large windows allowing natural light to enter. Since the customer does not have a specific preference, it is generally recommended to choose a height that balances all of the previously mentioned considerations. A height of 8 to 9 feet is often a reasonable choice, providing adequate illumination without being excessively high or low. When planning the layout and installation of recessed lighting, it's beneficial to consider a few additional factors to optimize the lighting design. Firstly, determine the appropriate spacing between the recessed lights. This spacing will depend on the lumen output of the fixtures and the desired level of illumination. A general rule of thumb is to space the lights apart at a distance roughly equal to the ceiling height. Secondly, consider the type of bulb or light-emitting diode, LED, to be used in the recessed fixtures. LED are energy efficient and long-lasting, making them a popular choice for garage lighting. Select bulbs with a color temperature that provides comfortable and functional lighting. A color temperature in the range of 3000 to 4000 Kelvin is often recommended for garages. Thirdly, incorporate dimming capabilities into the recessed lighting system. Dimmers allow for adjusting the light level as needed, creating different moods and conserving energy when full brightness is not required. Fourthly, ensure that the wiring and installation of the recessed lights comply with all applicable electrical codes and safety regulations. If unfamiliar with electrical work, it is best to hire a qualified electrician to perform the installation. The National Electrical Code, NEC, provides guidelines for safe electrical installations. Fifthly, think about the specific tasks that will be performed in the garage. If the garage will be used for activities like woodworking or automotive repair, consider adding supplemental task lighting in those areas. Task lighting can consist of under-cabinet lights, spotlights, or portable work lights. Sixthly, evaluate the existing natural light in the garage. If the garage has windows or skylights, take advantage of the natural light to reduce the need for artificial lighting during the day. Seventhly, consider the overall style and design of the garage. The recessed lighting should complement the architecture and decor of the space. Choose fixtures with a finish that matches the other hardware and accessories in the garage. Eighthly, plan for the future. Think about how the garage might be used in the years to come and choose a lighting system that can adapt to changing needs. Ninthly, inspect the recessed lighting system regularly to ensure that it is functioning properly. Replace any burned out bulbs or malfunctioning fixtures promptly. Tenthly, when selecting recessed lighting fixtures, pay attention to the concise and housing type. The concise refers to the diameter of the opening in the ceiling. The housing type refers to the construction of the fixture and its suitability for different ceiling types. There are several types of recessed lighting housings. Firstly, insulation contact IC. Rated housings are designed to be in direct contact with insulation. These housings are safe to use in insulated ceilings and can help to prevent heat buildup. Secondly, non-insulation contact. Non-IC rated housings are not designed to be in direct contact with insulation. These housings must be installed with a minimum clearance from insulation to prevent overheating. Thirdly, shallow housings are designed for use in ceilings with limited space. These housings are shorter than standard housings and can be installed in tight spaces. In addition to the housing type, it is also important to choose the correct trim for the recessed lighting fixtures. The trim is the visible part of the fixture that is installed in the ceiling. There are several types of recessed lighting trims. Firstly, baffle trims have a series of rings or grooves that help to reduce glare. Baffle trims are a good choice for areas where glare is a concern. Secondly, reflector trims have a reflective surface that helps to direct light downward. Reflector trims are a good choice for providing bright, focused light. Thirdly, adjustable trims can be tilted or rotated to direct light in different directions. Adjustable trims are a good choice for highlighting specific objects or areas. Fourthly, wet location trims are designed for use in damp or wet environments such as bathrooms or showers. Wet location trims are sealed to prevent moisture from entering the fixture. When installing recessed lighting in a garage, it is also important to consider the wiring and circuitry. Firstly, ensure that the wiring is properly sized for the load. The wire size should be large enough to carry the current without overheating. Secondly, use the correct type of wire for the application. For recessed lighting, it is generally recommended to use type NMB cable, which is a non-metallic sheath cable that is suitable for dry locations. Thirdly, install the recessed lighting fixtures on a dedicated circuit. A dedicated circuit will help to prevent overloading the electrical system. Fourthly, use a ground fault circuit interrupter (GFCI) outlet for any recessed lighting fixtures that are located near water. A GFCI outlet will protect against electrical shock in the event of a ground fault. In addition to the technical aspects of recessed lighting, it is also important to consider the aesthetic aspects. The recessed lighting should complement the style and design of the garage. Firstly, choose fixtures with a finish that matches the other hardware and accessories in the garage. Secondly, consider the color temperature of the light. A warm color temperature will create a cozy and inviting atmosphere, while a cool color temperature will create a more modern and energetic atmosphere. Thirdly, use dimmers to adjust the light level as needed. Dimmers can help to create different moods and conserve energy. Fourthly, consider the overall layout of the recessed lighting. The light should be spaced evenly to provide consistent illumination. By following these tips, one can create a well-lit and aesthetically pleasing garage space with recessed lighting. The National Electrical Code (NEC) provides comprehensive guidelines for electrical installations, including those related to recessed lighting. Several articles within the NEC are particularly relevant to recessed lighting installations. Firstly, NEC Article 410 covers the requirements for luminaires, lamp holders, and lamps. This article provides information on the types of luminaires that are permitted, the installation requirements for lamp holders, and the types of lamps that can be used. Secondly, NEC Article 410.16 specifically addresses recessed luminaires. This section outlines the requirements for the installation of recessed luminaires, including the clearances required from combustible materials and the requirements for insulation contact (IC) ratings. Thirdly, NEC Article 314 covers outlet boxes, device boxes, and conduit bodies. This article provides information on the types of boxes that are permitted, the installation requirements for boxes, and the requirements for supporting boxes. Fourthly, NEC Article 310 provides guidelines for conductors for general wiring. NEC Table 310.15b16 provides ampacity ratings for insulated conductors rated up to and including 2000 volts. Fifthly, NEC Article 400 covers flexible cords and cables. Flexible cords and cables are often used to connect recessed luminaires to the electrical system. This article provides information on the types of cords and cables that are permitted, the installation requirements for cords and cables, and the ampacity ratings for cords and cables. Sixthly, NEC Article 210 covers branch circuits. Branch circuits are the circuits that supply power to the recessed luminaires. This article provides information on the types of branch circuits that are permitted, the installation requirements for branch circuits, and the overcurrent protection requirements for branch circuits. When installing recessed lighting, it is important to consult the NEC and follow all applicable requirements. This will help to ensure that the installation is safe and compliant with code. Regarding voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause lights to dim, motors to run slowly, and other electrical equipment to malfunction. The NEC recommends that voltage drop on branch circuits not exceed 3% and that voltage drop on feeders not exceed 5%. To minimize voltage drop, it is important to use conductors that are large enough for the load and to keep the length of the conductors as short as possible. The NEC provides tables that can be used to calculate voltage drop. One such table is NEC Informational Note number 2 to Table 310.15b16. Regarding ambient temperature correction, the ampacity of a conductor is the maximum amount of current that it can safely carry. The ampacity of a conductor is affected by the ambient temperature. If the ambient temperature is high, the ampacity of the conductor will be reduced. The NEC provides tables that can be used to determine the ampacity of conductors at different ambient temperatures. One such table is NEC Table 310.15b2. It is important to correct the ampacity of conductors for ambient temperature to ensure that the conductors are not overloaded. Regarding box fill calculations, outlet boxes, device boxes, and conduit bodies must be large enough to accommodate the conductors, devices, and fittings that are installed in them. The NEC provides rules for calculating the minimum size of boxes. These rules take into account the number and size of conductors, the number of devices, and the size of any fittings. It is important to calculate the box fill to ensure that the box is not overcrowded. Overcrowded boxes can overheat and cause fires. For example, let's consider a scenario where 14/2 non-metallic sheath cable is being installed in a metal box. The number 14 wire has a diameter of 0.641 inches or 1.63 millimeters. According to NEC Table 314.16 bone, each number 14 conductor requires 2.0 cubic inches of free space within the box. If the box contains 6 number 14 conductors, then the total free space required is 12.0 cubic inches. Therefore, the box must have a minimum volume of 12.0 cubic inches to comply with the NEC. It is always advisable to consult the NEC and local codes for the most up-to-date and accurate information on electrical installations. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Safety should be the foremost consideration in any electrical project.